Here's a quick overview of NMap, which is a network scanning tool. Rather than describe what that is, I want to show you how to use it, and I think that will illustrate what it is actually a bit better. It can really be used for a lot of different things. I'll show you the two common ways that you'll need to use it for the upcoming labs. So first thing, two different versions. If you're using Windows, then you have the access to the NMap UI. This is the graphical user interface version of it, and I think most people find it a little bit more user-friendly. If you're on Linux, then we have the command line interface. To get the NMap version, you can just go to the NMap website. If you scroll down on the Downloads page, in this center section, we have Windows Microsoft binaries and latest stable self-installers right here. After you install it, you're going to have a program on your system that looks like this on the left, and I'll show you that running in my virtual machine here. So after you install it, you'll have a program that looks like this. I'll show you how this works a little bit in a moment. And the other thing to notice is if you run the ipconfig command at command prompt, you'll have your normal network connection, but you're going to have this additional NPcap loopback adapter. And that's a device that NMap installs so that it can observe your network traffic and do some things with your network. So don't be surprised after you install NMap that you find this new adapter in your system. If you're on Linux, then we're going to need to install using apt and a Debian-based system. For other distributions, you'll have to look up the install command. You need to run sudo apt install nmap. If your system is set up for using sudo, that will allow you to run this command as an administrator. Some systems you'll have to use switch user, su, and then a dash first to become root, to become the administrator, and then you can run the apt install nmap command. But it's a very simple install process on Linux. You don't have to go to a website, you don't have to do any extra steps. That's quite convenient. And this is a very popular tool, so there's lots of documentation out there. If you need some additional help, you want to find out what other kind of cool things this software can do, just Google for it. For example, when I was putting my notes together, I found this page that explains all the different presets in the NMap, for example. And it'll tell you what they all do and what the equivalent command line is, and there's just tons of material out there like this. Alright, so after you have it, that's great. So what can it do? And two primary ways that we're going to be using it. The first is called host discovery. And it basically answers the question, well, what's out there? What's out there on your network? If there are network devices installed and running, how would you know that they're there? Unless you set up the network, well, we can use this tool to scan it, and any device that is configured to respond to a ping will let you know that it's there. So the host discovery is done with the ping scan. You specify a range of IP addresses, and it'll just simply send a ping to each of those devices. If it's on, available, and configured to respond to a ping, then, well, it will answer back, and you'll now know about it. If we run it on the command line, we're going to use the -sn switch, and then your IP address range. In NMap, I'll show you. You just type in the address range that you want to scan. Say, for example, 10.0.0.0/24. That's 256 addresses. We can simply choose the ping scan and click scan, and it will start showing you the results in the main body of the window. Works the same way on the command line here. I already tested out all these commands, so nmap -sn 10.0.0.0/24. If I hit enter, it's going to send 256 pings out, and tell me what's responding. Well, these 4 devices are out there. Okay, and here they are. As I mentioned in my notes, you can also use the dash notation instead of the CIDR notation. You can, if I wanted to scan all the addresses that end in the value of between 0 and 255, then I can just type it in that way. 10.0.0.0-255. It's going to do the exact same scan. It's just a different way of notating the IP address range. So if you're not that familiar with CIDR notation, then this is probably easier for most people. Okay. If we want to scan a larger range, we can certainly do that. This /16 or with a dash notation, that is 65,000 some addresses. So it will take some time. It's not too bad, but it will take some minutes to run before it produces all those results. So if you're going to be scanning a large range, just be prepared to wait a bit for the results. You're running at the command line, it may even take a little while to produce any results at all. You might be wondering if it's even running. Okay, so that's really a simple thing to do. This ping scan will tell us, well, what's out there listening and responding to pings. Once we know what's out there, we can identify the available services on those devices by doing other types of scans. And generally, we're going to scan for open ports and usually on a single device. Because our services generally are assigned well-known ports or commonly used ports, if we can identify an open port, then we probably know what kind of service is running on that device. Running this in the graphical user interface is simple. You're just going to type in your IP address and then choose the regular scan. That will ping the device and then check to see if the most common 1,000 ports are open or not. We can also do an intent scan plus all TCP ports, and that's going to check the entire available port range. And this is helpful if devices have services configured on non-standard ports, which is actually pretty commonly done. So this might be something that you want to do to find out if, in fact, that's the case with that device. So let's take a look and see what this looks like. NMap here. Let's just say, for example, let's scan our gateway 10.0.0.1, and I'm going to select regular scan. I click scan, and it'll start producing results fairly quickly. The intent scan definitely takes longer. Intent scan plus all TCP ports will take probably a couple of minutes to run. This regular scan's a really good way to start, though, because it's so quick. And if it has common ports that are open, it's going to find them pretty much right away. All right, and on the command line, we can run that same command. I'll do a NMap and then just the IP address, NMap 10.0.0.1. That's going to do a regular scan. With a regular scan, you don't need to specify any additional switches or options. If you just type in NMap and an IP address, it will assume you want to use a regular scan. Of course, the same results as NMap. Since we're on the same network, we're scanning the same device. And so we came up with port 53 TCP, port 80 TCP, 443 TCP. And it's guessed at what these services are that are running on it, but if we know our common ports, then we know port 53 is DNS. There's probably a DNS server running on this machine. Port 80 is open, that's HTTP. That's our standard web port, not encrypted. And then 443, HTTPS, that's normally our encrypted HTTP. So we know what's open on this device, and it kind of immediately gives us some clues as to what services it's running. You'll have to do a bit more detective work if things are defined on non-standard ports. For example, if HTTPS port is open, but for an admin configuration page for some service, it'll often be configured at a non-standard port. That's a bit of a security by obscurity kind of a concept, but it does reduce the amount of random traffic that that device will see on that port. So those are the basic functions of NMap. Notes are here, and we'll review this in class pretty extensively in this week's project.